All right, let's talk about standard deviation. All right. Now, we just talked about variance, and let's take a look first of all at the units on variance. All right, so let's kind of break it down though, because the deviation from the mean, which is x minus the mean, is just going to be in ounces. So maybe I don't want to say equal, but it's the units are ounces, is in ounces. Ounces. Okay, so the units of the deviation from the mean is ounces, because I'm just taking ounces minus ounces, and that's going to tell me how many ounces I am from the mean. When I square it, so x minus mu squared, when I square it, then essentially what I'm going to end up is square ounces. Ounces is, well, let's see. Square ounces, right? Because I'm squaring it. Square ounces. Okay. Just like if you calculate the area of something, you take feet times feet, and you get square feet, right? So in this case, we get square ounces. Now, it's kind of a meaningless unit. I'm not sure what that means exactly. And that's kind of the issue here. So when I take x minus mu squared times the probability. Now, the probability is unitless, right? Because it's just how many out of how many, right? It's the, it's the frequency of occurrence out of the total number of occurrences, right? So it really is unitless. So this is also in square ounces. Square ounces. So when we sum those all up, right, we're summing up all these probabilities times the square of the deviations from the mean, it gives us a number that is in square ounces. All right, so the variance. So the variance is in square ounces. The variance is in square ounces. Square ounces. Which is kind of meaningless. And what is a square ounce? I don't know. So it would be nicer to have it in ounces, because then it means something. It's a little more meaningful. And that's the whole idea behind standard deviation, is just to take that kind of meaningless variance number, which is in square ounces, and turn it back into something that, makes more sense. It's in ounces, so deviation is in ounces, right? So our deviation is in ounces instead of variance, which is in square ounces. So here's the definition of a standard deviation. It's just the square root of the variation. All right, so we're taking square ounces and square rooting it, so we end up back with ounces. All right, so once you have the variance, getting the standard deviation is simple. You just take the square root of it. So let's take a look at example 3, right? So we already know that for brand A, our variance was 0.1, or sorry, not 0.1, 0.01, 0.012. That's the variance that we got. And so to compute the standard deviation, which we use this, it's a Greek letter. It's sigma, but it's a lowercase sigma. All right. So I think before we had the uppercase sigma, meaning the sum of, right? Lowercase sigma is like that. Okay. So this is also a sigma, but it's a lowercase sigma, Greek letter. All right. So I take the square root of that, and I get 0.1095 ounces. Okay, so now my standard deviation is in ounces. And for brand B, we can calculate the standard deviation for that just by taking the variance that we got, which was 0.042. And that gives me 0.2049 in the units. The units are ounces. Ounces. All right, that's all there is to example 3. So the next one is just another example. We've done potato chips. Now we're going to do battery lives. And so take a look at it. And try it out. And I'll meet you in the next video for the solution.